Hello and welcome to this video on simplifying a complex rational expression by simplifying the numerator and denominator separately. Alright, so in this video we're going to see what are called complex fractions or complex rational expressions. And a complex fraction is simply a fraction in which the numerator and denominator, or one or the other or both, have another fraction in them as well. So you have fractions within fractions. I've just got a few examples here of we're going to simplify, meaning write the expression as a single rational expression and a simple one as well. So where there's only one numerator, one denominator, no fractions in numerators, no fractions in denominators, and the numerator and denominator have no common factor. All right. So I begin here with an example where there are some numbers. Alright, so hopefully you can see why this is an example of a complex fraction. See, I've got a fraction, and usually in a textbook or worksheet that you're looking at online, whatever, usually the longest division bar or longest fraction bar, or the one in bold, like that's really a lot thicker than other ones, is going to be our main division. So if I wanted to, I could write this expression here as, this whole thing in the numerator, this 1/2 plus 2/5, put that in parentheses, and then anytime you see a fraction bar, I could put a division sign for these too, but anytime you see a fraction bar, that means division. So this whole numerator, 1/2 plus 2/5, divided by this division symbol here represents this bar, okay, and then this whole denominator, right? So in the denominator I have 1 minus 2/5. So you could write this as this as well. These actually mean the same thing, but hopefully you can see why it would be called a complex fraction, because it is a fraction, right? You have a numerator and denominator above and below the main division bar, and then inside that numerator there are fractions as well, right? There's a fraction of 2/5, a fraction of 1/2. Inside the denominator there's a fraction 2/5. So fractions within fractions, complex fraction. But our goal is to write a single fraction that is simple at the end. One numerator, one denominator, no fractions in numerators, no fractions in denominators, and also simplified, right, so that there's no common factor between the numerator and denominator. Alright, so this particular method, we're going to go over actually I'm going to make two videos on this. This first one is on the method of where I simplify the numerator and denominator separately, and then just remember that division, right, whenever you're dividing, division is just multiplication by the reciprocal. Okay, so the first thing, we're going to simplify the main numerator and main denominator. I'll just say simplify the numerator and denominator separately. Alright, which I'll do off to the side. Alright. So over here, let's look at our numerator. All the stuff above the long division bar, the main division bar. So I've got 1/2 plus 2/5. Now, if you remember in previous videos of mine, or you remember from previous material you've read, hopefully, and if not, if you don't remember it, go look it up. Try to refresh your memory. When you add or subtract fractions, you try to simplify the sum of two fractions I've got here. You need a common denominator, right? The denominators need to be the same. So I cannot add these right now, right? One has a denominator of 2, the other has a denominator of 5. So I use the least common denominator, right? Now the least common multiple of 2 and 5 is 10, right? So for these two, the least common denominator is 10. And what we do is rewrite each of these fractions as an equivalent fraction with a denominator of 10. And that'll involve multiplication by 1. So I'm going to multiply the numerator and denominator of each of these fractions by the same number. So the 1/2 here, I need to multiply the denominator by 5 to get a denominator of 10. And you can't just multiply the denominator by a number. You have to also multiply the numerator by that number. That way it's like I'm multiplying by 1, right? 5 divided by 5 is 1. So what I get will also be equal to 1/2. Same thing for the 2/5. I'm going to multiply the denominator by 2 to get it, the denominator to be the LCD, the 10. And I'm also going to multiply the numerator by 2. Right? So it's, again, like I'm multiplying by 1, and the fraction I get there will be equivalent to 2/5. Alright, so after doing this, this will be 5/10 plus 4/10, right? 2 times 2. And 5 times 2 in the denominator. And once you get the denominators to be the same, common denominator here, that will be the denominator of the sum, when you put them together. The only things you're actually combining when you add and subtract fractions are the numerators, right? So the denominator is 10, 10, 10. The numerator is going to be 5 plus 4 or 9, right? So I've simplified the numerator. Right. And then over here I'll simplify the denominator, right? Again, I wrote a single fraction where the numerator and denominator have no common factors. This is as simple as that gets, one fraction. Great. And then over here I'll do the denominator. Right. The denominator is 1, all the stuff below the main division bar, so all this, or in the parentheses over here after the division symbol. 1 minus 2/5. Now recall that if there is no denominator, technically you have a denominator of 1, right? Anything can be divided by 1. So this is the same thing as 1 over 1, right? 1 divided by 1 is 1, minus, and then 2/5. And the denominators are 1 and 5. So hopefully it's obvious that the least common denominator, the least common multiple of these two is 5, right? 1 times 5. And then I'm going to change the fractions to equivalent fractions with 5 as a denominator. So this first fraction, 1 over 1, right, the 1 here, I'm going to multiply the denominator by 5 to get the denominator to be 5, right, 5 times 1. And again, you have to multiply the numerator by the same number as well. This other fraction, the 2/5, already has a denominator of 5. So I don't need to do anything to that one. That's already good. Alright, so then multiplying this out, the first fraction here is 5 times 1 divided by 5 times 1, so 5 divided by 5, right? And you can see that that's equivalent to 1, right? The original thing I had. Minus, and then the 2/5 I did not change. And just as before with the numerator, once the denominators are the same, that is going to be the denominator of the sum or the difference, right? And this, again, this is only when adding and subtracting. You need a common denominator throughout. And it's the numerators that you combine, right? So this numerator minus that one, 5 minus 2 is 3. Okay, and that's completely simplified, right? 3 over 5 is one single fraction. There's no fractions within the fraction, right? And 3 and 5 have no common factor other than 1. Great. Right, so then, after I've written this and this, the numerator and denominator, I've simplified them. in part 2 is just to remember what division means. So I'll say step 2. Remember that division is just multiplication by the reciprocal. Alright. So looking back at my original problem, I have the 1/2 plus 2/5, that end up being 9/10. Alright, so I have 9/10, and we saw that here, right? 9/10 for the numerator. So I'm replacing this numerator with 9/10. The big division bar, right? The main division bar is still there. And then the denominator, the 1 minus 2/5, that was 3/5. So I'm replacing that with 3/5 all underneath the main division bar. Again, we saw that here, 1 minus 2/5 is 3/5. Or, like I said, you can think of this main division bar. You can always rewrite division as the division symbol. This is the same thing as 9/10, the numerator, divided by, and then that denominator, 1 minus 2/5, was 3/5. Okay. And I have put up videos before, a video before on dividing fractions. Pardon me. And I've said the same thing there. Division is multiplication by the reciprocal. So when you see 9 divided by 10, that's the same thing as 9 times 1/10. When you see 9/10 divided by 3/5, or 9/10 divided by 3/5, this is the same thing. Right, both of these mean the same. This is the same thing as 9/10. Alright, so the numerator doesn't change. It's the divided by the denominator that changes. Dividing by 3/5, right? Dividing by 3/5 is the same thing as multiplying by the reciprocal of 3/5. Remember, the reciprocal of a fraction is just flip it over, numerator becomes denominator, denominator becomes numerator. So divided by 3/5 is the same thing as times 5/3, 5/3. Okay. Alright, and then now when you multiply fractions, again I've put up videos on that before, multiplying rational expressions. You're gonna basically, I'm gonna factor everything, factor every numerator and denominator. Okay, so here comes the factor everything. 9 is 3 times 3. 10 is 2 times 5, right? So that's 3 times 3 over 2 times 5. Then we have multiplied by, and then 5 and 3 are prime. And then the multiplication part. Now remember, when you multiply fractions, you don't need the same denominator. Alright, it's only when adding and subtracting do you need the same denominator. When you're multiplying fractions, you just simply multiply the numerators. And so all I'm really going to do here is list the factors. We have 3 times 3 times 5. So 3 times 3 times 5 in the numerator, or you could write 3 squared, right? 3 to the second power, but that's same thing as 3 times 3. But I got 3 times 3 times 5 in the numerator, and 2 times 5 times 3, or 2, again, it doesn't matter what order these come in when they're real numbers. So I'll write them in lowest to highest. 2 times 3, I have factors of 2, 3, and 5 in the denominator. And then if you look at these, you can see, hopefully it's clear now, that they have the numerator and denominator do have common factors. 3, right? They both have a factor of 3, and remember, these technically become 1 when you divide them out. 3 over 3 is 1. And they also both have a common factor of 5, right? So you can again cancel those and make them 1. So the only factor I'm left with in the numerator is 3. The only factor I'm left with in the denominator is 2. And there you go, and that's as simple as that gets. So my original expression, right, this crazy thing up here, 1/2 plus 2/5, divided by, and then 1 minus 2/5. If you were to do that, punch it in a calculator, which you'd have to punch it in like this, right, with the parentheses around the whole numerator, divided by, and then parentheses around the whole denominator. But if you were to actually do that in a calculator, you would see that you'd get something equivalent to 3/2, 3/2. Or, if you want to write this as a decimal, right, this would be 1.5, right, 1.5, or as a mixed number, 1.5. All these are the same thing. Okay, but what we're trying to do for the purposes of this video is write a single rational expression where the numerator and denominator, a single fraction where the numerator and denominator have no common factor. So I'm going to leave this here, 3/2. Okay. Now, throughout that problem, we had no variables, right? That problem there is all numbers. So you never had to worry about, hey, what if I plug in a value for a variable that makes my denominator 0 somewhere? Makes a denominator 0. You can't do that. Well, I didn't have to worry about that with this exercise, but I do in the next couple examples, right, where variables actually show up. All right, so my next example. All right, and just because there are variables there does not change my procedure for simplifying. So I'm asked to do the same thing. Here's this fraction with fractions in the numerator and denominator, a complex fraction, 3/y minus 1 above the main bar. Again, typically the longest bar, or the one that's thickest or in bold in a book, is the main division. Right, and like I said, I could also rewrite this thing if I wanted to as the quantity 3/y minus 1, and then that main division bar I replace with a division symbol, divided by, and then all this stuff underneath it is the main denominator, all of it, the quantity 9/y minus y, and close parentheses. So you could write this like this if you wished. And what I'm going to be doing is the same thing I did in the last example, right, that I'm going to do for all my examples in this video. To simplify a complex fraction is work with the main numerator, right, everything before the main fraction bar, everything above that, everything before the division symbol, however you want to look at it. And we're going to simplify that. Right? So I'm going to work with the numerator, right, which is this 3/y minus 1. Now remember, when I say 3/y minus 1, that's 3/y minus 1/1, right? Again, this thing doesn't have a denominator, so technically you can always say it has a denominator of 1. The LCD, right, the least common multiple of the denominators, the least common denominator, is just y, right? There's a factor of y in this, just 1 in that denominator. So now I'm going to rewrite them as equivalent fractions with a denominator of y. The first fraction already has a denominator of y. Okay, so this second fraction, this 1/1, I'm going to multiply the numerator and denominator of this by y. Right, that way I get a denominator of y. And so we have 3/y minus y/y. And now I have what I want, right? These two fractions have the same denominator, and I'm subtracting here, right? When you add or subtract, you need the same denominator. And once you've got that common denominator, that denominator is going to be the denominator of the difference, or the sum if you're adding. And all you're combining are the numerators, right? So the numerator here would be 3 minus y. Okay. Or if you want to write that as negative y plus 3, that'd be fine. I actually probably prefer that. I'll get to that later, where I might write this as negative y first, then plus 3, in descending order. But for right now, I'll leave it like this. All right, so there we go. Single fraction. The numerator and denominator don't really have any common factors, right? If you were to factor this, you could factor out a -1 and make it -1 times y minus 3. So you have a factor of -1 and a factor of y minus 3. But there are no factors of -1 or y minus 3 in the denominator. So that's simplified. And then we'll look at the denominator, everything below the main division bar next. So that's all this here, or after the division symbol if you wrote it this way. So I'm taking 9 over y, and then minus y. Well, same problem here, right? I have something without a denominator. Well, if it doesn't have a denominator, it has a denominator of 1, technically. So that's 9 over y minus, and then y over 1. And this has the same LCD, right? Same least common denominator. The denominators only have factors of y and 1, so just simply y would be the least common multiple of those. And I'm going to make sure now that I get equivalent fractions with a denominator of y. The first fraction has already got a denominator of y, so that's great. It's the second fraction that I need to change, right? I'm going to multiply the denominator by y. 1 times y will give me that denominator of y. Multiply the numerator by y as well. Alright, so we've got 9 over y minus, and then y squared divided by y. And then now I have what I want. Both denominators are the same. So when I'm subtracting, the resulting difference will have that denominator as well. And you just combine the numerators, 9 minus y. Okay. Or, sorry, 9 minus y squared. Alright. And again, in a minute here, I'm going to write this in descending order and as negative y squared plus 9. But just because I don't have a lot of room on the side of the page here, I'm just going to keep it like this for now. Alright, so continuing on the next page, I have my numerator simplified, I have my denominator simplified, right? Now we can rewrite the numerator. Now we can rewrite our original problem. Alright. So we have here, the 3 over y minus 1 was 3 minus y over y. Right, we saw that there. Right. Divided by, and then the denominator under the main division bar here, 9 over y minus y, that's 9 minus y squared over y. Okay, and we saw that just there, right here. Again, or you could write it this way, right? This first, the numerator there is 3 minus y over y. And then the main division bar, we had a division symbol there. And then the denominator, the 9 over y minus y, was 9 minus y squared all over y. Okay. And then here, now that I have my numerator and denominator totally simplified, here comes the division part. Division is just multiplication by the reciprocal. All right. So this is equivalent to 3 minus y over y. All right. The numerator is not changing. It's the stuff after, right? Instead of dividing by this fraction, I can say that I'm multiplying by the reciprocal of this fraction, right? Which would be y divided by 9 minus y squared. Right? Okay. All right. And now here's where I'm going to rewrite these polynomials in descending order because I just prefer that. So instead of the 3 minus y, I'm going to make that negative y plus 3, right? In negative y term first, then the positive 3 term, okay? Divided by y times, and then y over, and then the 9 minus y squared. I'm going to rewrite that in descending order again. So negative y squared first, and then positive 9, right? Then plus 9. All right. So then here comes the same. Again, it's the same procedure where I'm gonna factor everything. Alright, I'm going to factor all these numerators and denominators. And the reason I put them in descending order like this is, again, I prefer it 1. Alright, you don't have to. You could actually leave this as 3 minus y and this is 9 minus y squared and perfectly factor this just fine. You know, this is a difference of squares here. But I like it this way. I just like to stay consistent, and I like to put all my polynomials in descending order, standard, in some sort of standard form when I'm working. Alright, so in factoring, you know, the numerator of this fraction has 2 terms, so I look for the greatest common factor, which is 1, but the lead coefficient is negative. Alright, and I've mentioned this in several other videos before. I'm going to mention it again here. When the lead coefficient of a polynomial I'm factoring is negative, I'm going to factor out the opposite of the greatest common factor, or the negative greatest common factor. So that would be negative 1 here. And the same thing is going to happen down in the denominator of the second fraction. You see how the lead coefficient is negative for this one? Alright, so in both of those I'm going to factor out negative 1. Alright, so the numerator of this fraction, I pull out a negative 1, or you could just write a minus sign. Right? A minus sign implies times negative 1. And then when I remove a factor of negative 1, what's left over up there is y minus 3. Right? And you can double check, distribute that, you get negative y plus 3. Okay, and then divided by y. You know, y factors to just y, right? You know, y doesn't really factor any further, so the only factor in this denominator is y. All right, then times, and then the next fraction, the numerator, trying to factor it. Well, it only has a factor of y. And you know, these factors that have just a single term, I don't usually put parentheses around unless it's like a negative number, just to, you know, because it looks messy when you have a negative number on its own. I don't know why. And then down here, this denominator, same thing. I'm going to pull out a negative 1. All right, and when I remove a factor of negative 1 from these terms, I'm left with y squared minus 9. Well, that y squared minus 9 is a difference of 2 squares, so that can actually factor even further. Alright, so bear with me here. So I've got a factor of, you know, negative 1 times y minus 3 over y times, and then y in the numerator here, divided by, and then negative 1. And then this y squared minus 9 factors further. That's y squared minus 3 squared. That'll factor to y plus 3 times y minus 3. Okay. And then comes the multiplication. Alright, now when you multiply, I've mentioned this before in the video, when you multiply, the denominators do not need to be the same. You know, I don't need to change this to look like that. This is fine. When you multiply, you're just simply multiplying the numerators and multiplying the denominators. And so basically all I'm doing here is going to be listing the factors in the numerator. So in the numerator, I have a factor of negative 1 times, and you know, you can rearrange the order. I got a factor of y times a factor of y minus 3. Right? That's the whole numerator, that product. In the denominator, again, I like to put you'll see that most books, and I also like to put numerical factors first. So I've got a factor of negative 1 in the denominator times a factor of y, and then I have times a factor of y plus 3 times a factor of y minus 3. Alright, great. And then finally, now I have a single fraction, which is what I wanted, right? This whole time we want just a single fraction, but I want it simplified. I want no common factors in the numerator and denominator. So I'm seeing the common factor of, you know, negative 1, so I can divide that out. That'll become 1. They have a common factor of y. They also have a common factor of y minus 3. All right, lots of common factors here. Now be careful. Notice I have eliminated all the factors of the numerator. That doesn't mean there's nothing up there. That doesn't mean there's 0 up there. Remember, all these become 1 technically. Right? Anytime I divide out something, anything divided by itself is 1. So really what I'm left with in the numerator is the number 1. All right, so when all said and done, finally, the numerator is just 1 divided by, and the denominator, the only factor left in the denominator is the y plus 3. Okay, and since it's the only factor left, I don't really need to put parentheses around it. but you can if you want. It wouldn't be wrong to put parentheses around this. Wonderful. So our original problem, all right, this guy way back here, here it is, this 3 over y minus 1 divided by 9 over y minus y, that will have the same value as what I have here, 1 over y plus 3. But not all the time. Right? Not all the time. You can't plug in whatever you want. If these are truly equal, you could replace y with anything, and this value would be equal to this value. But remember that you can't divide by 0. You cannot have 0 as a factor in a denominator, or just a denominator of 0 anywhere. Division by 0 is undefined. It makes no sense. So I'm going to look, and it can't happen at any moment throughout the problem. So looking back through this problem, I'm going to point out to myself some values I could not replace y with. Y cannot be equal to these values. Well, right from the get-go, I see 3 divided by y, 9 divided by y. I see a factor of y in the denominator, and these little denominators here and here. So if I replace y with 0, that'd be bad, right? So y can't be 0, because if y were 0, I'd have 3 over 0, 9 over 0 in these little fractions. That can't happen. And then looking throughout the problem, right, going back to the first page, again, you got factors, you got y's in denominators, so y can't be 0. Looking at this page, again, I'm seeing y in denominator, y, and then now I've got 9 minus y squared in denominators. So look here, right? There's a factor of y plus 3 in this part of the problem. There's a factor of y plus 3 in this denominator. So y can't be negative 3 either, because if y were replaced with negative 3, I would have had a factor of 0 in this part of the problem. I would have had a division by 0, and that's wrong. Same thing here, right? At the very end, you see y plus 3 in the denominator, so y can't be negative 3. But I'm also seeing one other factor showing up. One other factor with a variable showing up in denominators, and that's this y minus 3 right next to it. All right, yeah, it got eliminated here, but it's still in the denominator in this problem somewhere. So y minus 3 is a factor in the denominator, so that means y cannot be positive 3. If y were positive 3, this factor would be 0, and we'd have a division by 0 here, and that would be wrong. And that looks like all the factors with a variable that I'm seeing, right? Yeah, there's this factor of negative 1 popping in the denominator somewhere throughout this problem, but negative 1 is a number, and it is not 0. It's not going to be 0 ever. So here we go. This is it. The value of the original expression I had, all right, this 3 over y minus 1, all divided by 9 over y minus y, that value will be the same as just simply 1 over y plus 3, no matter what I plug in for y, except these 3 numbers here. All right. Do not plug in any of these 3 numbers, because you'll have 0 in a denominator somewhere throughout the problem. But let's try something. Let's try a value. So off to the side here, I'll say let's try plugging in a value for y and seeing if that's true. All right, and do as many as you want. You'll see that you'll get the same value for this expression as you will for this expression. So I think a nice one here would be, how about negative 2? If y is replaced with negative 2, again, try anything you want as long as it's not one of these 3. Plug in negative 1, plug in 8, plug in 1,000,000, plug in 10, 15, 1/5, who cares, right? Just not one of these 3. Alright, if y were negative 2, let's go back up to this original expression here. So you'd have 3 divided by negative 2, which would be negative 3 halves, right? 3 divided by negative 2, then minus 1 in the numerator, and then division, and then the denominator you'd have 9 divided by negative 2, so negative 9 halves, and then minus negative 2. And again, replacing all the y's with negative 2. And then this is just like my first example in the video now, right? I have a complex fraction. Up in the numerator here, this would be negative 3 halves minus, and then I hope you see that 1 would be 2 halves, 2 over 2. Negative 3 over 2 minus 2 over 2 would be negative 5 over 2 in the numerator. And then this here, the minus negative 2 is really just plus 2, right? So you have negative 9 over 2 plus 2, or 2 over 1. And you get a common denominator, which would have to be 2. That'd be negative 9 over 2 plus 4 over 2. Right? 4 over 2. Negative 9 over 2 plus 4 over 2 would be negative 5 over 2 again. And anything divided by itself is positive 1. Right? So the value of the original expression is positive 1 when the value of y is replaced with negative 2. Well, let's see the fraction I got at the end. 1 over y plus 3. That'd be 1 over, y is replaced with negative 2, so negative 2 plus 3. That's 1 over negative 2 plus 3 is 1. 1 divided by 1 is indeed 1. So yes, they are the same. And that'll work out. It won't always be a value of 1, but the value of the original expression will be equal to the value of 1 over y plus 3, no matter what I plug in for y, just not one of these three numbers here, because you can't divide by 0, ever. Alright, so I've got one final example, where one of the denominators has more than one term, so it maybe makes it a little more complicated, but not much more. So again, I'm asked to simplify this complex fraction, right? There's fractions within fractions. Now this one's nice, because if you notice, all right, let me write out, my main division bar is right here, right? Again, the longest one, or the thickest one. This is my main division. And you could also write this way. I could say that, take all this stuff above is put it in parentheses. Take 1/2 plus 2 over p plus 1. Put all that in parentheses. And then the main division bar, symbolize that, rewrite that as a division symbol. And then this denominator, I guess it's already a single fraction, so I don't really need the parentheses, but I got p plus 5 divided by 6, right? It's already just a single fraction, not the sum of two fractions. It doesn't have two terms, it just has like one term. So I don't really need the parentheses around it, but I could write it like this, right? And again, the main division right there, that symbolizes that bar. And I see why this one's a little nicer, is because I don't have to do as much work. See how the denominator is already a single fraction? It's p plus 5 over 6. So the only thing I have to do this time, before I change division into multiplication by the reciprocal, is just work with the numerator. Alright, so the numerator is this 1/2 plus 2 over p plus 1. And I'm going to try to put these together. The least common denominator would just be, this factor is just 2, and this factor is just p plus 1. So it's just 2 times p plus 1. 2 times the quantity, p plus 1. Or if you want to distribute, there'd be 2p plus 2 would be the LCD. But as you've seen you probably, if you're watching my videos, you've seen in other videos where I'm adding and subtracting. I like to keep my denominators factored until the very end. It just makes simplifying the fraction at the end that much easier. Okay, so now I'm going to multiply. So this half here, I'm going to multiply the denominator by the quantity p plus 1, and also the numerator by p plus 1 to get that LCD. And then this fraction, right, the denominator has, just the one factor of p plus 1. It's got multiple terms, so I'll put in parentheses. I'm taking all this, and I'll multiply it by 2. Alright, to get those same two factors as the LCD. And do the same for the numerator, right, again, so it's like I'm multiplying by 1. So now I had the first fraction, 1 times p plus 1 would just be p plus 1 for the numerator. And my denominator I like to keep factored, right? 2 times p plus 1. Okay. And then plus, and then the next fraction, my numerator 2 times 2 is 4, divided by, and then again the denominator is that LCD 2 times p plus 1. And now they have the same denominator, so that'll be the denominator of the sum, 2 times the quantity p plus 1. And then you're just adding the numerators. Now remember, you're adding this entire numerator plus this entire numerator. Now I don't really need the parentheses around this one because it's just got one term. It just has one term of 4. But you know, I like to put parentheses around polynomials with more than one term when I'm adding and subtracting. But p plus 1 plus 4 would simply be p plus 5. All right. And the denominator, right, so I've simplified, and there's no factor, you know, this is all one factor up here, right? You can't factor this any further. So I mean, if you want to put this in parentheses, it wouldn't be wrong. I wouldn't, I mean, I just did, but but all of that is the only factor. The only factor up here is p plus 5, and there's no factor of p plus 5 in the denominator. So this is as simple as it gets. So now it's a single fraction, totally simplified. And now we look at the denominator, and I mentioned already, right, the denominator is already a single fraction. It's p plus 5 divided by, you know, 6. And, you know, I'll leave it like that. Now, we'll factor stuff in a second here after I rewrite it. Alright, so I've got the numerator as a single fraction, simplified. I've got the denominator as a single fraction, simplified. Alright, so again, what we're going to do is take the original and rewrite it. Alright, so the original, my numerator is this guy here, right? This p plus 5 divided by 2 times the quantity p plus 1. Alright, that was the numerator. Big fraction bar there. Alright, this replaced all this. Divided by, and then the denominator was this p plus 5 divided by 6. Again, you could also always rewrite it this way with the division bars. You have p plus 5 divided by 2 times p plus 1 divided by, and then the p plus 5 divided by 6 over 6. Right? Same thing. These mean the same thing. Okay. Now comes, since I've simplified the numerator and denominator, made them both one fraction, now comes the multiplication by the reciprocal part. Right, this is equal to p plus 5 divided by 2 times p plus 1. Right, the numerator, that first fraction, doesn't change. It's the division part that changes. Right, instead of dividing by p plus 5 divided over 6, that's the same thing as multiplying by 6 over p plus 5. All right. And now comes the part where, when I'm multiplying two fractions, I factor everything. Factor every numerator and denominator completely. All right, so here's where I factor numerators. P plus 5, that's it, right? It's a polynomial with two terms. You look for the greatest common factor. The greatest common factor is 1. So, I mean, you could say this is p plus 5 times 1, but the only factor up there is p plus 5. So, again, just to indicate that it's all its own factor, I'm going to put it in parentheses. All right, it's got multiple terms. So p plus 5 is how that factors, and then we already factored that denominator earlier. That was the LCD earlier. 2 times the quantity p plus 1 times, and then 6 factors more. Right, 6 factors to 2 times 3. So I have factors of 2 and 3 in that numerator. And then again, same thing as this guy here. P plus 5 is its own factor. P plus 5 factors to, p plus 5 times 1. Alright, and then the multiplication part. Again, I'll say it again. When you multiply fractions, you do not need the same denominator. I don't need to change these denominators so they look the same or whatever. You just multiply the numerators, multiply the denominators. And all I'm doing really is listing the factors. So when I multiply these two fractions to make a single fraction, the numerator has factors of, there's a 2 times a 3 times a p plus 5. And when I multiply the denominators, there's a factor of 2 times a factor of p plus 1 times a factor of p plus 5. All right, great. And now we simplify. All right. look for what are there common factors in the numerator and denominator. You can see them. There's factors of 2 and this p plus 5 factor. All right. So when I'm all done now, this is equal to 3 over, or 3 divided by, and then the only factor left in the denominator is p plus 1. So since it's the only factor, I don't need to put parentheses around it. You can, again, it doesn't hurt to put parentheses around that, but it's the only factor left, so no need. So great. Let's go back to the original and check it. All right, let's see. So here's the original problem, all right, the original complex fraction. And what we're saying is that the value of this crazy fraction up here will be equal to the value of this simple fraction no matter what I plug in for p, with a few exceptions. All right, remember, you can never have, throughout the entire problem, at any moment, you can never have a denominator of 0. So there are some values I can't plug in for p here. So let's look back through the problem and see, is there ever a denominator with a variable in it that could possibly be 0? All right, so look at right away I'm seeing there's a little denominator, p plus 1. And that's even in the denominator at the end. P plus 1 is a factor in some denominators. So p cannot be replaced by the number -1, right? Because -1 plus 1 would be 0. You'd be dividing by 0 at some point, and that's wrong. All right, so keep looking through. So I still have, p plus 1 in the denominator here. P plus 1 denominator, p plus 1 in the denominator, p plus 1, p plus 1, p plus 1. Working through this problem now. Okay, look, after this part, when I changed from division to multiplication by the reciprocal, now I'm seeing a factor of p plus 5 showing up in denominators. So p plus 5 is in some denominators a factor of p plus 5. So that means p cannot be -5 either, right? Because if the value of p were -5, you'd have 6 over 0 here during this part of the problem, and you cannot have a division by 0. And those are the only factors with variables that I'm seeing, right, up until the end here. This was right before the last step. This was the last step. I mean, yeah, there's a factor of 2 in the denominator, but again, that's not 0 ever, right? That's just 2 all the time. So this is it. The value of my original complex fraction, all right, so go back here. So the value of this original complex fraction is equal to the value of this simple fraction here, just so long as I don't plug in -1 or -5 for p. All right. And if you want to test that out, check it out. Try plugging in some numbers for p, for p. Well, I'm going to do that. Let's try that here. All right, let's try a value for p. And again, plug in whatever you want. Just so long as it's not these two, -10, -18, 1/5, 1/3, pi, square root of 2. I'm just going to try a simple one. How about 0? All right. How about when p is 0? All right, when p is 0, let's go into the original, see what that value is. We have a half, right? A half plus, and then 2 divided by 1. I'll write 2 over 1, right? Because when p is 0, this would be 0 plus 1 for that denominator. Over, all right? And then 0 plus 5 is simply 5, so you have 5/6 in this denominator here. All right, and then I have a complex fraction, kind of like my first example from this video. And let's combine the numerators. Now 1/2 plus 2 over 1, you need a common denominator. That'd be 1/2, and then I would multiply this one by 2 over 2, right, to get a denominator of 2. So 1 over 2 plus 4 over 2, that's 5 over 2 in the numerator. And then 5 over 6 in the denominator. And then this is 5/2, instead of 5/2 divided by 5/6. That's the same thing as 5/2 times the reciprocal of 5/6, or 6/5. And what we're getting here is 30 divided by 10, right? Again, you could do the factoring here, what I'm kind of skipping a little bit, but 5 times 6 is 30, 2 times 5 is 10. 30 divided by 10 is 3, all right? So the value of that expression that crazy complex fraction here. When p is 0, the value of this whole thing is 3. Look at the 1 here. We have 3 in the numerator divided by a number placing p with 0. So you have 0 plus 1 in the denominator. That's just 3 in the numerator, 1 in the denominator. 3 divided by 1 is indeed 3. So yes, they are the same. And that will happen, and again, the value won't always be 3, right? If you replace p with 1,000,000, you're not going to get 3. But whatever you replace p with, the value of this expression will be equal to the value of this one, this simple one. Just don't replace it with these two, right? You'll be dividing by 0 somewhere, and that's wrong. Okay. All right, so that's it for this method on simplifying complex fractions. I'm going to have another video soon where I go over a different method using the least common denominator to help simplify complex fractions. And as always, at the end of these, I like to say, try your best, try the best you can to get and understand your material on your own before you go looking for help. Because I have found that people tend to remember things better when they get it on their own. They took the time to get it on their own. For some reason, it means more to them. It just sticks better. So read through the material, read through the author's examples, maybe even try to work out the author's examples before you read how the author did it. Sorry if you can hear my dog, I'm sorry. Work through problems in the back of a section, check out your answers in the backs of books. Just keep practicing. Don't give up after the first or second attempt either at a problem. If you're still struggling after a few attempts, read back through the material again. Maybe there's something when you go through it the second or third time that didn't click the first time. You'll have an aha moment or something. But if after several readings of the material, if after several attempts at problems, you're still having trouble, then it is not a sign of weakness at all, whatsoever, to go asking for help, go looking for help. That is what other people are there for. Talk to a teacher, talk to a tutor, a friend in the class, someone who knows the material, and look for videos on the subject. Plenty of resources online. Videos like this one or ones out there that are much better. I assure you they're out there. Just go looking for them. And just keep at it, stay persistent, and try to go in it with a good mindset too. Don't go into it thinking, I'm going to hate this, I hate this, I hate this. I've always hated math, because guess what? You're going to hate it still even more. Try to get into some mindset where I'm going to try to enjoy it. I'm going to try to enjoy myself, try to have fun. And you'll be amazed at the difference it makes when you go into something with an open mind like that. So keep at it, stay persistent, keep practicing, have fun, and thank you for watching.